In this lecture, we're going to discuss about the late binding, how late binding we can achieve in C++. It is just opposite of the early binding which we was discussed previously. Okay, what is the need of late binding? It is found that during program execution, sometimes some identifier name did not get resolved during the compilation. I repeat again, it is found that during compilation of your code, at the time of compilation of your code, some of the identifier name is not able to bind to a particular address at compile time. Okay, so all those such identifier name will be get binded at runtime, and this mechanism is called late binding, and it is also called dynamic binding. Okay, because it gets binded, name of the identifier get binded at runtime. That means after compilation is complete, during the execution the name of identifier gets binded. In C++, one way to achieve this late binding is function pointers. So we'll see next one example how function pointers will help us to achieve late binding. Because if we want to know the difference between a variable and a pointer, look at this definition available over the web. It is mentioned that accessing a variable name by its name is faster with respect to accessing a variable name with its pointer. Okay, so I repeat again, accessing a variable by its name is faster with respect to accessing the same value of memory block using pointer. The reason is that in the last example we have shown that during early binding, when we compile our code, all the variable or identifier name get resolved at compile time. But when you use pointer, it needs one more extra step. We called it dereferencing, so it gets binded at runtime. So let's see one example how late binding we can achieve in C++. So in this code, what I did, I have declared one function pointer called fptr. What kind of function this pointer can point? It can point a function whose accept argument of type int and return type is void. Means function return nothing and accept an argument of type int. So in this code, I have declared two functions here. One is fun1, another is fun2. Both argument type is int and return type is void. So that means fptr is can point both of this function, but one function at a time only. Okay, and inside this function I simply perform addition operation, one with integer addition and another I am performing an integer value get added with a float value and simply print the result. Now look at the main method. When our program execution started from the main method, first this pointer get created. At this point, fptr is not point any function. Now, next what I did, fptr have the address of fun1. Remember, to assign address of fun1, either you can write name of the function directly or you can write ampersand operator before the function name. In old C++ compiler, this ampersand operator is required. But if you use the update version of C++ compiler, then it is not mandatory. Because we know that function name always carries the address of the function. Now, look at this, function is not called yet. Function address is just assigned to a pointer. And we know that when we want to use a pointer with certain variable or to access a memory block, we need to use dereferencing mechanism. So next, we are calling fptr. We are calling fun1 using fptr. This function call will be resolved at runtime. Why? Let's try to understand this first. Why this function call get resolved at runtime? Suppose what we did, we have a function written. In this block, there is a function. Which function? Fun function is there. Fun1 in this block. Okay. Which is outside of the main method. And here is another block which is actually the main method, which is get executed at the beginning, main method. Now when you use some function pointer to get address, okay, to get address of this fun, then during compilation, then function pointer which had certain memory block, this is function pointer which have certain memory block, it have what is the value of this block? This block will have the address of what? Address of fun1. Okay, so up to this much compilation will be done, binding is done at compile time. But when we try to call the fun1 using function pointer, what compiler will do? Compiler will first access the fptr memory. When compiler accesses the fptr memory, it finds that address of fun1 is reside in the fptr memory. So next, to call the fun1 using the address of fun1, it needs further time. So this time is left in runtime. So that's why when we call fun1 using function pointer, this function pointer gets call result done at runtime. So that's why he called it late binding. Similarly, at next step, we are assigning the address of another function because fptr can point a function with integer type argument and return type is void. And in this example, fun1 and fun2 both satisfying this criteria. Only one argument of type int and returning type is void. So remember, I repeat one more time, assigning the address of fun1 is done at compile time, but when we call this function using function pointer, it follows two-step process. Step 1, fptr memory get access first, and next address of fun1 is used to get jump to the function body. This is the reason this function call will be resolved at runtime. But when you use the simple function call, then first step is not there. Directly we are using the address and jump to the function body. So that's why runtime will take more time and we left it for the late binding. So we called it late binding or dynamic binding. I hope the idea of late binding in C++ is clear. In next lecture, we're going to see how to achieve late binding using virtual function and base class pointer to derived class object.